Good day, and welcome to this presentation about the new version 3.0 of LITESTAR 4D, the program for the integration of product and lighting planning design management. We will briefly introduce the main features introduced with this new brand new version. And we will start with PhotoView, the Photometric data manager, introducing the new batcher feature, the automatic photometric file management. This feature generates various types of child files in different formats like ULUMDAT, like IS and TM14. I can add also the OXL format, the one developed by us, but also graphics in JPG, PNG, so it means raster formats, but also in vectorial formats like the EPS, the encapsulated PostScript. And this is done from few parent files, usually LDT, IS, or OXL. So we can have few files who are parent files, considered as parent files, and from here we can generate many other files. For example, this is the case like the one of a luminaire, which is characterized by the same photometry, but it has different price list codes depending on the color of the luminaire. So the experience that we had in the market is that usually it is much better not to give a single file with the main part of the code, but the full code should be the code of the file, so that the people in the market can easily recognize the file and the luminaire without having to search and think about what am I using. This feature is introducing many advantages from our point of view. First of all, the flexibility, because this is a very flexible file, allowing you to generate a large number of files of any kind, let's say all the files and all the graphics that the program can manage, that the PhotoView module you see here can manage. But also, we can add some other reports, and this is one of the other main features that we introduced recently with the launch of the program. So we can also generate automatically all the reports characterizing the photometry of and colorimetry of the luminaire as they come from the laboratory. So it means that we can make any procedure completely automatic. So anything regarding the laboratory, anything regarding the data management can be easily managed and in an automatic way. So you can understand that this is absolutely a very powerful system to manage data, and by the end it is very simple. Let's say that it is obviously a dream that comes true for the people working at the laboratory, working at the marketing office of the different companies, whenever they have to manage data updating. And this is something very interesting, especially now that we are managing LEDs. With LEDs, we know we are living a world which is completely different from the previous world of conventional lamps. And why? Because LEDs are changing, for example, their characteristics so frequently that it is something that was unknown in the previous world of conventional lamps. So more and more you need automatic tools in order to process the large quantities of data characterizing the luminaires. We're going to show you how it works as soon as we finish the introduction of all the features of LITESTAR 4D 3.0. Let's come now to the Lightcast module, so the lighting design and planning module. One of the main features that we introduce is the association of Luminaire 3D and photometry, and all is then saved into an OXL format, an OXL file. So we can say that now with our program, no longer just the photometry. So 3D and the photometry can come all together in a very simple way. And if we consider that the OXL format is open, it means that it can be used by any other program willing to do it. You can access our website and you will find the description of this format with all the fields managed by the OXL file. You can realize how powerful can be such a tool. So the advantages is obviously the ability to freely create your own luminaire, managing 3D and photometry all together in one single object. Most of the operations done now by the people in the market is collecting LDT files or IS files and then the 3D file. So there are at least two operations involved and two operations in importing the files into any program. And then you have to assemble together and create a group, and so this is done in a much easier way with the OXL file because it is carrying all the information together with the product. And if you consider that the OXL file can also include, besides photometry and 3D, the datasheet of the luminaire, PDF files, Excel files, whatever you want to use to characterize the product you're dealing with, you can imagine how powerful the OXL can be for you. And if we go back to the association of 3D and photometry, you will see through the demonstration that this is absolutely a very simple and intuitive way to manage those files. Another main feature that we introduced with the program is the tunnel feature. So we split, as usual, the feature about this environment into two, the guided or wizard tunnels and the advanced tunnels. The difference is that with the guided tunnels, we usually manage a very simple layouts. Okay, yes, it is possible to manage different sections, but at the end you can manage a single luminaire placed in one row at the right or at the left or in two rows. So it is a very simple luminaire configuration. While on the other hand, the advanced tunnels can manage more complex situations, and you can add tunnels, for example, with variable interdistances, and manage also circuit switchings. So we, as we said, manage luminaire files. We can manage a free-road configuration, and we can have various sections of rectilinear tunnels parametered. So it means that in any case, this is not something fixed. It is something that you can configure so that you may have the section of the tunnel exactly as the reality. One more, new materials management. It was a completely revised management of materials and texture. And the advantages that from our point of view we introduce is that now it is much simpler and more intuitive to manage texture and materials. Configurations of various types, and then it is unfortunately it was not possible to have it straight away in this in this version of the program. It will be later on during next 2 or 3 months, we guess, the option to save the material configuration, the material file into an XML file we called OXM. This is an error, OXM. So like we have, on the other hand, we have the OXL file, we are going to make available to the market also another file type, which is structured in the same way like the OXL file, where we had during the past year quite a lot of experience. So we now make a step forward also in the direction of managing another object like materials and texture all together in a single XML file. It means that at the same file we are storing the parameters related to the material. It could also be a material with a defined BRDF, and we can also at the same file save the image related to the texture. Another interesting feature that we introduced with this new version is the most used products catalog function. It means the feature that you have at the right side of the main window of Lightcast here. This is the catalog of the most used products, where you can store your own products. So if you are used to work with some specific luminaires, you can use this section to store them so that you don't have to go too far to have them immediately input at your design. As I'm going to show you, you will see that it is in this case very simple to add or to remove luminaires from this section. And the files could be both LDT-IS files or OXL files. The difference is that with ULUM.DAT or IS files, you don't have the image carried through the file. So what will be visualized, it is only a photometry. On the other hand, with the OXL, when it is supplied complete with an image, you will have the image in place of the photometry. Another feature that we introduced is the switching management. So it is possible now to collect luminaires into different layers, switching layers, and then create different light scenes. The advantages, you have luminaire grouping, where we also introduce a color in order to recognize immediately the different switchings. And through here, okay, it is possible to manage different switching also here in a very simple way. One more, results management. We practically revolutionized the way to manage results, and especially the way to present them. So for example, what you see here, we have that this configuration is in function of the surface, the observer, and the calculation type. So it could be illuminance, horizontal illuminance, it could be TV illuminance or luminances, and you can collect data and information in function of the different types. So we may have the calculation and then the surface and observers, or a mix of it. In this way, so it is very easy for the people working on a project to have the complete control on the results. It is also possible with this new version to delete the results that, for example, are not of interest for the printouts. So this is the first filter before passing to the printouts. Okay, also there then it is possible to select what to print and what not to print. But if we prepare it over here, it is, from our point of view, it is more practical to manage. One more as we worked on the lighting levels, on the switchings, we also work on the general layers, so that now whenever you had a regular or irregular working plane, it is then automatically headed to the layers group, a specific layer dedicated to the working planes. So in this way, it is possible to confirm to the program if you want to calculate with the working plane, if you want to run the calculation with the working planes or not, or if you want to visualize the working planes at the during the lighting design, because sometimes the working planes may disturb you, so you can remove them through this feature, just clicking on here. This other is to block the layers. So for example, if you don't want to touch them, so you're working on some parts of the project and you don't want to touch them and, for example, to move them, so you can block them. And if you want to calculate, it is the third column. If you unselect, you want the layers, that the working planes won't be considered at your calculation. Okay, let's come now to another main feature which is working pretty well, the web catalog. The web catalog can be considered as a dynamic data center for products management. It means that it is a tool that we developed with the main goal. It has to be very, very easy to manage, and it has to come to the product with very, very few clicks, maximum 5 clicks. So wherever you are, through the search engines supplied with the web catalog, you can come to the product sheet. You can see here exactly in less than 5, maximum 4 clicks, depending on the feature. Depending on the search engine. It means that we have also some ways to come to the product sheet, which is less than 4 clicks. At that point, whenever you are at the product sheet, you can then download various file formats. You can have it here an example. So it means that if you want to download from here an LET, you just have to press it here, and the downloaded file will be shown at the bottom part of the web catalog page, and then you can straight away drag and drop the photometry into your lighting design program or any other application using the LDT. But in this example, you can also produce the label following the European standard 874 for energy efficiency. You can manage RTF, you can manage the XF, so you can add many files. And it is also possible to configure this web catalog in function of the manufacturer's needs. From my point of view, another very interesting feature related to this product, it is that it is supplied in 32 languages. Let's say that 26 languages are the base ones, and we added other 6 languages corresponding to some of the countries of the European community, like Denmark, Sweden, Estonia, etc., because they must be supplied for the printouts of the labels, the energy efficiency labels. It means that with our program it is also possible to select the language you want to use for the printouts, because the European norm is saying that you have to print the label in function of the country where the product will be sold. In the same way, also related to the previous feature, in particular regarding the label system, the energy efficiency label system, we added a new feature, which is the web survey. It means that we can supply you a service through which, from a request coming from for example, the manufacturer's website, we can give back the label exactly in the format and exactly following the language selected by the request. So it is something that we always keep updated in function of the needs. It is something that it is not asking you to develop your own. You just have to connect to our system, and we will help you to produce all the labels. In this case, this is not a feature, but it is quite a big change related to the past. So up to this new version, we were used to send an information, an email regarding the expiration of the maintenance contract. So from our office, we were used to send emails informing the customers about what was going on with the license. From this version, this will be completely managed automatically by the system. So it means that whenever you run the program, a message will appear starting 30 days previously to the expiry date, telling you that few days are missing to the expiration date, and the system will also show you the date of the expiry of the contract. So it means that from here, if you want, you can access our e-commerce at WebOxy, our website, and from there you can upgrade you can update your license, or you can download the form through which you can input all your data, you send it to us, and we will contact you consequently. Okay, let's come now to the demonstration of some of the features that we have introduced with this new version. But in any case, if you want to have a customized demonstration of the system, please write us or call us, and we'll be pleased to organize a GoToMeeting special for you. Thank you. Okay, we can now start with the demonstration of the different features, and we start with the batcher. So, as we said, the batcher is an automatic feature allowing you to produce a large number of photometric files. So, you have to run PhotoView, you select the batcher. Let's say that this feature is not available through the open or professional configuration. It is a feature that will be automatically added in case of customizing the program for a manufacturer, for example. So it is included at the custom, or it is included at the batcher, at the batch feature, which is something apart that we had in function of the request of the manufacturer. Why? Because we could see up to now that it is absolutely impossible for us to establish a single feature which could be available and which could be valid for anybody. It means that we have a customer asking usually something different one from the other. So we customize exactly the feature in function of the request. So whenever you select the batcher, this window will appear. You have to add the CSV, which is the Excel file through which you pass the information to the system. How is it working? So the program must have an input folder where we have the child files. We have the Excel file. Let's pay a look to the Excel file in here. So we drag and drop, and what you can see here, it is a set of different columns through which you define the original file name, which is the file name of the child files you have here at the input folder. The destination file name, which will be used for the production of, in this case, the LDT, the IS, and the OXL files. And then the other columns, the new measurement name, the new luminaire name, the new measurement code, the new luminaire code, then the description of the lamp, the color temperature, the lamp flux. This is a main point, because this feature is really helping you whenever you have to change the flux, but knowing that the quality of the photometry, so it means the 3D volume of the photometry will be pretty the same, so there won't be changes in the photometry, but only in the flux, because a new generation of LEDs will introduce new fluxes. So you can also define the color rendering index, the lamp power, the lamp quantity, the dimension of the luminaire, because you may use, for example, the same photometry for different luminaires, even with different luminaire shapes. Then the beam diagram, the beam and polar diagram, which are the files that the program, in this case, following this configuration, will automatically produce and store into different folder. Where are the files being saved? They're going to be saved at the output folder. You can see that here we have no other folder than this one, but whenever we select the Excel file, remember that before starting this feature you have to close the related Excel file visualizer through the Excel. So in this case I say I don't want to make any change. I double click or select open, and the program automatically will create the photometry folders and the folders for the images, the folders for the graphics. And one by one will start and save the different files. You can imagine that if we describe this situation with a very limited set of files, we managed only 3 files as input and output. But so it is quite simple. You can think that we can manage it manually. But if you are dealing with thousands of files, you can imagine how helpful can this feature be. And especially if you want to produce, as we had a chance to see with a customer of ours during the past weeks, if you can also add all the reports coming out from the laboratory, this is really the complete circle of what you need from the laboratory. And it is really possible with the batcher to make your laboratory and the work at the laboratory as automatic as possible. If we pay a look now at the different folders, we can see that we created the IS files, we created the LDT files, the OXL files. I want to add one more point about the OXL files. There is another main difference considering the OXL file in place of the LDT and IS. Why? Because the OXL file is also capable of storing inside the file also all the parameters related to the photometry. So it means that we can store the currents, we can store the voltage before and after the ballast, for example. So any parameter related to the measurements can be stored at the file. So at the end, it is, from our point of view, quite more interesting to start not from the LDT files, but to work at the laboratory and save then all the information at the OXL files, which will become the reference files, the child files, in place of the LDT and IS. Okay, let's come now to the demonstration of the OXL editor. So the feature allowing you to create an OXL file including and heading all together the photometry and the 3D of the luminaire. To do that, you have to select the Tools, OXL Editor. From here, you select the folder where you saved, where you stored the 3D and the related photometry. You simply have to drag and drop. As you can see here, we are managing the OBJ file, the OBJ format, 3D file format. We can also manage the 3ds. You drag and drop, and the program will automatically upload the 3D of the luminaire. Through here, you can analyze if the luminaire was made in the proper way. Let's say that the work done by the program is working with meters, but in this case, if we leave meters, then we will have a luminaire of more than 100 meters. So it means that the scale has to be changed, and we change it through here. So we say that it is a millimeter. Now it is corresponding to reality. We also see that this luminaire is not placed with the luminous area horizontal. So we have to rotate the luminaire on the x-axis, the red one, of 90 degrees. So in this case, it was placed in the exact position. Now we come to the OXL editor, so it means that in here we have to import the photometry. Here we have a photometry in IS format. From here I drag and drop, and the photometry will be automatically headed to the luminaire. But in this case we are lucky because the 3D of the luminaire and the photometry itself are exactly placed with the luminous point exactly at the origin of the 3 axes. But in case it is not, you can move the 3D. You can move, for example, the photometry also graphically in this way. You can also turn graphically, or you can exactly define the parameters. So for example, if you want to say that the photometry is corresponding to an asymmetric luminaire and the photometry is coming out tilted 45 degrees, then we apply 45 and the photometry will be rotated of 45 degrees. So let's come back to, sorry, 0. And let's now save the file. So we say that I want to save to the same folder and say that this is the luminaire Alba 140. I save, and the photometry was added here. It means that now we are ready to use this photometry straight away into my lighting design program. And if I select to visualize the photometry, then you will have the 3D plus the photometry. And this is a block you can move in any direction. Okay, let's come now to the tunnel module. As I described through the presentation, we have two different ways of managing the tunnels: the wizard and the advanced. Let's start with the wizard. So let's start with a very simple tunnel. From here, from the first section appearing at the top left, we can define the road characteristics, the standard to apply, the type of observer, and the carriageway type. At the right, we can select the section of my tunnel. I can define the length of my tunnel. Let's say that now we want to design a very simple tunnel. The width, which should correspond to the dimension you have here. So in this case, it is necessary to change, for example, the sidewalk and place it at 2 in order to achieve the 14 meters width. Then the height and the abutment, which is the vertical part of this tunnel, of the tunnel section that we selected, so the vault one. We can say that it is up to 3 meters. Then next step is to define the luminaires distribution, one row on the right or on the left, two opposite rows, two staggered rows, and define the position of the single row or the two rows in function of the two edges of the road, so the two sidewalks of the road, the luminaire height, installation height, the spacing distance, and the tilting angle. In this case, we do not consider this, we consider these values in case you have to rotate the luminaire. Why? Because sometimes you may have some luminaires which are not perfectly positioned. So it means that the photometry, for example, for an asymmetric luminaire, it is not in the proper plane, which is usually the C0 plane. It is placed on the other side. So through this feature, through this parameter, you can rotate 180 degrees the photometry. Now it's necessary to select the photometry, and to do that we select one catalog, and from this catalog we select the corresponding luminaire. So for example, we may add this one, so simply drag and drop. The photometry is this one, the image, and from here I can say that I have finished. So the tunnel is will be displayed in 3D. You can then visualize also the luminaires and see that they are not placed in the proper way. So in this case, you have to go back to the panel and change the parameters. So in this case, it is staggered rows, and we rotate them 90 degrees because we want to send the asymmetric flux towards the center of the road, as we have here. At this stage, we can start with the calculation and visualize if my design is corresponding to the needs. So we may compare the result with the standards. The program can calculate in function of the CIE 88, which is the CIE recommendation for tunnel lighting, but also it is also possible to calculate in function of the Italian standards, because we can manage two different standards, an old one and the new one. Once we have finished, we have all the results visualized through the result summary window, and through here you can select, for example, to visualize the carriageway A, which is the single carriageways that we have, in function of the different observers. So in this way, this is the visualization of the results we can convert into isolux curves, etc. If we go back, we can also convert the visualization from the textured visualization into false color visualization and select the curve from linear to logarithmic. If this is, let's say, the first step, then we can approach the project also from the advanced point of view. So we define the so-called permanent level. We can come back and, for example, add some other rows of luminaires, because at the entrance we must have a higher value. So from here, which is the standard, the base, the wizard module, we can jump into the advanced module, where we have the road characteristics described over here. So for example, from here now it is possible, if you want, to change the color of the sidewalk. We place them red, for example. And we can come to the luminaires, where we can add other luminaires, other rows of luminaires, simply doing in this way. So let's say that now we want to add this luminaire, which is a symmetric luminaire at the center. So we select this one. This new line of luminaires will be added. We can define the starting point. We can define the transversal position. Let's say that this one we place it at 6, always at 4 meters. The total number of luminaires will be 6, and the interdistance will be 5 meters. Through this column, we can define a value which is how much it will be increased the interdistance between the luminaires. 2 consecutive luminaires. So in this case, if we say that we had 10, it means that and the length is 80. So in this case, the program will add some luminaires in this new row, considering that from the first 2 luminaires with an interdistance of 5 meters, from the second to the third, there will be an interdistance of 5 meters plus 10%. So it will be 5.5 meters. This is something which is helping to reduce the luminance value the more you get into the tunnel. So if we finish, we will see that another line was added, and you can see here that the interdistance is absolutely variable from the other ones, which is the other two lines, which is constant. And if we run the calculation, at the end you will see that there would be a reduction in luminance values. Okay, the same as before. What we can see here is that, okay, it's really in the way that we said, the values are going down, but we are using a very narrow beam luminaire, which is not exactly what should be used at the tunnel, as you can see here. So it means that I must go back and select another luminaire. So let's say that I want to add some other luminaires, but it is not available over here. I can select it from from an available folder. So doing in this way, I select this one, and let's say that I have some IS or ULUM.DAT files or OXL files available through here, and I can say that I want to use, for example, this one. So I drag and drop from here. So I showed you that it is possible to select the luminaires from the available catalog, or it is possible to select it from an external folder without forced to use the catalog supplied with the program. At this stage, we can finalize and start again the calculation. Okay, finished. The situation is much better than before, and we can visualize through the false color diagram. Okay, let's say that it is possible through this module also to manage the Adrian curve. So it is possible to manage the luminance curve in function of the defined external conditions. So if we define the speed at the entrance of the tunnel, if it define the direction of travel, the type of installation, etc., then the program will automatically calculate the luminance curve, in case we have a photograph. So in this case, we should add an image that we may select from an external folder, like in this case. I have to fix the entrance and I have to select the different areas. Once I have selected the different areas, the program will come back with a luminance curve. We make it much faster, saying that the luminance at the entrance is 190. And once we say that, automatically the program calculated the related luminance curve, which is in function of the defined parameters. This situation is something that you have to check with your lighting. So the luminances that you have calculated should be compared with this green line. What is the blue line? This is an idea that it is now included at the Italian standard, And it is, from my point of view, quite an interesting idea. Why? For the simple reason that in case you're starting your tunnel in steps, so it means that you start with this one, and then you have steps, which means that it is not the luminances are not continuously defined like we have here, but it is approximated through steps. Then this curve gives you the limit. So the step shouldn't be above this line. And this is also a reference which is, by the end, very useful for two main points. First of all, it is helping you to find and to achieve the best uniformity, the variable, as you can see here, your uniformity, which means that you won't have big steps from one luminance level to the other. And the other one is to force the designer to study exactly the steps in case, and not to use more energy than needed. So by the end, it is really quite an interesting idea, helping the people managing the lighting design of tunnels. Okay. Let's pass now to the, okay, we're finished and we close it. To the analysis of the new feature about materials and texture. Let's select an interior project, the project for the interiors. And if we select, for example, the ambient, the room, we will come to this window. This is a very simple window, but quite strong from the point of view of the concept. So, for example, if you select from the surface column, then a single material, a single surface will be selected. But if you select from the material name column, then you will see that all the materials with the same characteristics will be selected. And automatically the program will show with the little points, you can see here, the selected surfaces. It means that if you want straight away to change the parameters related to this wall material, then you have to select this feature, and automatically you can change and apply the changes. Even if you want, you can change from the Lambertian material to a generic material, where you can define the diffusion, you can define the specularity, you can define the color, and you can define the texture. So, for example, let's say that we want to add where is it? A peculiar texture. So let's say we want to add wood on the walls. We select this one, and automatically the program adds the texture to all the selected surfaces. At this stage, we can also change the name and call it wooden walls, or define it in another way. So it was changed. This is quite interesting because the material was added to the list of available materials. So in this case, the wooden walls can be used also for other surfaces without having to define it once again. If we want to define a brand new material, it is also possible selecting this feature, where we say ceiling matte, exactly the same name. This is not sealing material. At this step, we select the texture in case. We want to use this one, and this texture is added to the scene. We define, for example, the specularity. We confirm. Visualize texture. Okay, this is a sort of Hunter Douglas for the ceiling. And from here, we start the calculation. And have the values and render it at the end. Remember that we defined almost 50% of specularity, so you have here the image of the couch we have here. Okay, so this is the material part. Let's come now to this section at the right about the most used product section. How can we manage it? How can we add other photometries? So if we select and we add a photometry to here, we have to do it in this way. We select it, we add it to the project. This is the brand new photometry and luminaire that we added. From here, I come to the luminaires list. I select the luminaire and I add it over here. As you could see, this is a photometry available in the LDT format, so ULUM format. So as I said, it is added here simply with the image of the photometry. But if we had a luminaire from here, let's say that we want to add this one to my design. We place it down. This luminaire, as you can see, it was created with the 3D of the luminaire, so it is an OXL file. From here, I drag and drop into here, and the luminaire was added to the list, and it is available with the image. So we say that we had this one simply with the photometry because it is coming with a ULUM file. In the other hand, we have this one coming with the image because it was supplied with the image and the 3D and the photometry all together. In case you want to delete one or more luminaires, you have to select them and press delete at the keyboard. The folder won't be deleted up to when you exit the program and you start it again. So automatically the list of the manufacturers will be added. I'd like to tell you that sometimes the files are not carrying at the first line the name of the manufacturer. In this case, the program will create a folder with no name. So you won't have any name at the top. Let's now clean up a little bit with the headed luminaires. So we remove the headed luminaires and we analyze the different switchings and how it works. So from here we come to the switching sections. As you can see, we have already defined different groups of luminaires, and you can see it straight away in function of the colors that were assigned to the different groups. So in this case we have an orange color characterizing the switching number 3. This one is for the first one, and this one is for the second one. So if I am in such a configuration, I mean with the photometric solid available, then it will be possible to immediately select or unselect, it means turn on or off the luminaires. So if we want to turn off these luminaires, we select this tag, and the luminaires will be turned off. So they won't have the photometry. At this stage, we can run calculation, and at the end, visualize the rendering and see how it works. Okay, so going back, I can say that I want to turn off those luminaires. I calculate again, and so I visualize another scene. As you can see, the calculation, even though we have a coach which is based on many surfaces, it is done quite quickly. And this is the new situation. You may, at this stage, render it. If you want to add new switchings, so for example, I select from the folder a new luminaire. So let's say we select the one that we added. So I put it here. I create, for example, a line of luminaires saying that I want to use this luminaire and have 3 luminaires on the X and 1 luminaire on Y with an interdistance of 1 meter on X. I don't want to delete the other luminaires. So 3 luminaires were headed at the position that I defined. I didn't change the starting position. So now I remove this one. I can say that I have now a group of luminaires. I select the group, I move it, I place it to the proper position. I say that this one is out, and automatically the program assigned the new luminaires to the first group. But clicking on the right button of your mouse, you can create a new switching 4. We change the color. Okay, and say that the selected luminaires be assigned to this layer. So let's say that now I want to study the new lighting with these luminaires, but without this. I start again the calculation. Okay, from here I select the working plane. I select the pseudo color, so it means the false color diagram. I select the isolines where I can change if they're not visualized in the proper way. I can select 200 with a step of 100. Confirm. So I reduced the number of isolux curve, and it is more readable, the diagram. So you can see here that we selected the working plane and all the results are related to the working plane. If I want to change and define the tree in function of the type of calculation, I select Calculation Observer Surface. In this case, we do not have any observer. This is useful when you have road lighting or tunnel lighting where you have to define an observer. But now let's go back to the list of the calculations. I select Luminance and I select wall 5, or for example the floor. And again I had pseudo colors and they were headed in here. And again in function of the surfaces. If we want to remove this visualization, so the isolux visualization, you can see it in function of the little icon that you have at the left of the description of, in this case, horizontal luminance. Then you have to simply press delete and that's it. And at the end, if you come to the summary of the results, you will find all the calculations in here. And again, as I mentioned, it is possible to unselect what to print also from here. Okay. Last point about this presentation is the web catalog new layout. So if we select this manufacturer, it is possible from here to have 3 different search engines. The technical search, which is based on a dynamic tree that you can configure in function of your needs. So for example, if you want to search in function of lamp power, product type, and source type, then you select this one and automatically the tree will be changed to lamp power, product type, and source. It means that you can configure the search, the technical search, in function of your needs. And let's say, as you could see, we always have a maximum of 3 steps. Because we found that if you had more, if you have the 4th, the 5th, etc., then it will be too boring, too complex for the people to search products. So in this case, I select 49, I select exterior interiors, waterproof luminaires. It is FD, this is the ILCOS code of the lamp. FD means fluorescent. And here you have the list. Up to now, we had to click only 3 times. From here, from this list, if I select the luminaire, I will come to the product sheet. And as you could see, with 4 clicks, I could come straight away to the product sheet. From here, it is possible to, let's configure properly this one. From here, it is possible to, for example, download the LDT file. And once it's here, I can straight away drag and drop it into the lighting design, or in case, straight away into my database. If I want to add this luminaire to the database, I don't have to, I just have to select the luminaire and that's it. I have to define that it is an FD lamp used at the luminaire, and straight away the luminaire was imported at the database. From here you can add images, etc., because being open the database, you can add whatever, anything you need. From here, as I mentioned, it is possible to have the instruction leaflet, the catalog page, to have the label, the energy efficiency label. You select and once it's down, you can open the label. In this case, it is saved in the PNG format, but we may also save in PDF or any other file format. And from here, we can access the datasheet, which can be converted and can be configured in function of the needs. So we can also add the image, but let's say that we have a maximum of 5 images that we can add to the datasheet. And at the end, it is also possible to switch it to the language that we want to use for the printouts. So for example, if we select Korean, all the datasheet will be converted to Korean. Only the text, if they were not supplied by the manufacturers, they will stay in English, because automatically the program is using the English if the translations are not available. So let's say that the program is not translating, for example, like using Google Translator. No, because it may be in future, but now it is much better to manage directly the translations. So in this case, we had the English, and from here you can print it to the PDF and then use the datasheet wherever you want.